let's go ahead and talk about our next question here and our final question, measurements to change. This is going to be similar to our deltas to state, but just slightly different. We have a pandas series containing some measurement. How do we determine the boundaries or determine where that measurement has changed? Let's go ahead and get started. We're going to be using our star trader dataset here. And in our star trader dataset, we will be computing the positions, aka when do my cumulative volumes change from positive to negative. That will indicate if I have a long position or a short position. Now, we can of course infer our sign from the volume. So if I am trading a positive volume of assets, that means I bought something. If I'm trading a negative volume, that means I'm selling something. And then the positions are calculated from the cumulative sum of the traded volumes whenever they cross over 0. So let's go ahead, I'll make my data and I'll show those data to you. This is just the first 5 rows. You can see that we have different dates, we have different portfolios, so different traders, and we have different assets, and of course a volume and a price for each of those assets. Our first question is asking us to identify the number of positions and compute the average buy price and the average sell price. Now in pandas, we'll of course read in our data, which look exactly as above. And then the first thing that we want to do is we're going to perform a group by operation. This group by operation is because we have multiple signals per, and this should actually be also on assets here. We're gonna have multiple signals per date for a given asset. So now by calculating the average or summing the total traded volume in a given day, as well as the average price for that day, I can work with these values having just one per day, one asset per day. And maybe I'll do something, yeah, this looks good. The next thing that I do, I'm going to need a lot of dependent columns here. So I'm going to use .assign, and the first thing that I want to do is I'll create a direction column. In this direction column, we're just indicating, did I buy something or did I sell something? And if I traded in a positive volume, then I bought something. If I traded in a negative volume, then I sold something. So it's fairly straightforward. Now, if you want to do this in production, or if you're running with a very large data set in pandas, using a .map to go from a Boolean type to a string type is not going to be your best friend. Instead, I would lean on something more like a categorical, if you're familiar, the categorical .from_codes class constructor, which is what I would reach for here if I was concerned with performance. Then I'll create a new dependent column called cumulative volume. This is simply the volume for my portfolio and my asset here, and I'm going to take the cumulative sum here. Then I can ask my position type. I can say, are we currently in a long or a short position? And all I'm looking for here is whether or not my cumulative volume is positive or negative. If it's positive, we're in a long position, and if it's negative, we are in a short position. And you can see here that EVQX, we transition from a long to a short position right on the second day. The last thing that I'm going to want to do, and this is the whole trick of this analysis, is I want to find the edges. I want to find when did I transition from long to short, or when did I transition from short to long? Well, we can do that just by looking at our data frame and comparing it with the shifted version of itself. And mind you, when I shift, I'm going to want to shift over, of course, both the portfolio and the asset, and then we can let the index alignment take us the rest of the way there. Finally, I'll take a group by cumulative sum across my portfolio and my asset just to create positional markings or boundary markings for each of these groups. Now I have an entity that I can actually perform a group by operation on, and that's my position count. You can see here, this is going to be a per asset count. Am I in a long position? Am I in a short position? And if so, how many positions did I have? Now, the next thing I'm going to want to do is I'm going to want to compute my final metrics here in the final phase of this analysis. The last thing that I want to do is I'm going to take a group by operation, and I'm going to investigate whether or not, I'm going to ask for what the average price is, whether it's a buy or a sell. Now, when I do this, you'll note that I have a shape data frame, right, where I have a multi-index, no columns, just a single series here, and I'm just investigating the portfolio, the asset, and the direction. I know that based on my question, I'm curious the number of positions and the average buy and sell price. And so if I think about this analysis, and then I think about the computation I need to perform in order to count the number of positions that I have, and this will be a group by here on portfolio and asset, just taking the maximum of my positions count, I can see that this index is simply just portfolio and asset, whereas this index is portfolio, asset, and direction. So how do I line these two things up? Well, the trick that we can use in pandas is going to be a pivot or a reshaping operation. In this case, I'll use an unstack to move my buy and sell to their own columns, and I'll suffix those. And now I have the same index here on my analysis here as I do in my ladder analysis. Then the final trick is going to be, how do I stick these two things together? I can concatenate these two entities together. You can see that's the approach that I'm taking here. And so I'll just go ahead and replace these with this, and we'll perform our group by on D. And of course we need our commas here. And this is how I would approach this problem in pandas, heavily using index alignment and using its reshaping operations as well. Now, polars is going to be just a little bit different. In polars, I can perform this computation lazily, or I can perform it eagerly. I'm going to go ahead and use the lazy approach by using the scan parquet, and I'll perform a lot of the same computations that we have already seen. Specifically, right, I'm going to be investigating each portfolio, each asset, and each date, and I'll actually put asset after that. And then I'll derive all of my dependent columns. So, and of course with polars, this is group underscore by. This is actually a fairly recent renaming in polars. And the last thing that we want to do, of course, is print out our data frame. So with this approach, we can see I've calculated my volume. I have one asset per day now per portfolio. And so we'll go ahead and we can just reuse all of our data sign. What I've done here is I've copied over the data sign syntax into with columns for polars, and I've largely kept as much the same as possible, just replacing my lambdas with the more transparent polars expression syntax. Now when we run this, you see that I get an error. I'm getting a column not found error. And the reason I get this column not found error is that polars by default will try and execute all of these computations in parallel. That means at the same time that I'm computing direction, I'm also computing my position counts. And then polars goes ahead and says, wait, for my position counts, I'm using a column called position type. And polars is correctly recognizing that column does not yet exist on my data frame. And so it's raising the error saying, I don't know where this column is. It hasn't yet been created. Whereas with data sign, we can use our ladder expressions to refer to former expressions, meaning I can refer to the direction column here in this line because I defined it on the previous line in pandas. Now in polars, there's a couple of different ways that we can take this. We can use multiple with columns because polars doesn't yet have that dependency resolving with a single with columns. So what I'm going to do is I'm just going to create two new columns, and then every time I have a dependency, I need to start a new expression, a new with column definition here. And you can see this does get me all the way to my expected output. Now, another thing that I can do, because we all use Python here, instead of relying on the out-of-band encoding that the with columns offers, I can simply just use an assignment expression and then use that same assignment, that same variable in a later with columns syntax or with columns call. Now I do need to actually have two separate with columns calls here because polars is interpreting this as an aggregation, which I don't think it is. And so this might be one of the times where relying on the optimizer is going to get you to the right place at the right time and give you a very good query 99% of the time, but there are going to be operations that are going to be incorrectly inferred, and you're going to be left scratching your head. How do I get around this? And you'll realize quickly with tools like polars or SQL, you can only try to push the optimizer so much to do a specific thing until you just have no tools left at your disposal to actually nudge the query planner into doing what you want it to do. Whereas with pandas, I can always make pandas do exactly what I want it to do because we're exposed to all of the internals that pandas has to offer. And whether that's going to be for better or for worse, whether I'm going to write a better pandas syntax than I can write what Polars will optimize for me, that's left up to debate. I know that some people can write very, very fast pandas code, and other people still learning the core concepts are going to write slow pandas code. And so this is actually what I really enjoy about Polars, is that if you're just starting out with it and you're using the Polars expression syntax, chances are Polars is going to help increase the speed of your actual query, of your actual transformations. And so we're performing the same types of operations that we saw before. And finally, we'll perform our aggregation. Now, of course, this is a group underscore by. What I really enjoy about this aggregation is note how I actually created my by and my cell columns. Previously with pandas, I had to perform a separate group by operation and an unstack, and I had to rejoin with myself. With Polars, I can actually take a column and I can filter it based on another column. And so this is actually letting me perform something almost like a pivot, but I'm actually not restructuring my data frame. I'm simply just adding new columns. And the best thing about this is pivot in Polars is not supported outside of the lazy API, meaning pivot is an eager only operation, but I can use this expression filtering in order to perform what would be the result of a pivot using Polars. And so the Polars expression is an incredibly powerful tool to have at your disposal. Polars is going to make a lot of the correct calls when it comes to optimizing your query or optimizing your code. I don't have to worry about necessarily writing this code faster or revisiting myself, because I can rely on my query planner, my query optimizer to actually make those decisions for me. And if a new version of Polars comes out, well, I'll just have to trust that they only made forward improvements to the query planner or the optimizer than hurt it. And so you can trust that with Polars, right, your queries are going to be fast and they're going to be reliable. With Polars, you do have to just reorient your thinking just a little bit, right? Move away from constantly reshaping your data or moving indices from one area to another. Those are a little costly in pandas as well. And so I wouldn't encourage you to reach for those right off the bat in pandas either. But you can see here that Polars lets us very easily, using things like the nested data types and using this expression filtering, we can actually circumvent a lot of the rough edges that pandas has and create some very powerful queries. Now, one caveat is that Polars isn't going to be supported by all of your favorite downstream projects just yet, but I will say this. You can freely convert from, or not freely, but you can convert from a Polars data frame into a pandas data frame. And with pandas 2.0 being out, if they're both back to using the same arrow in-memory layout, then we should be able to convert from a Polars data frame into an arrow back to pandas data frame without having any copies occur between the two, which is absolutely amazing. From there, we can work with all of our favorite tools, making sure that they're passed the correct data in the formats that they're expecting. Now, the one thing that you do need to watch out for is if you do need to transform from an arrow array into a NumPy array, that's of course going to incur you a copy because you're completely switching backends. They are working. There actually is work to actually prevent that, though, and telling NumPy how to work a little bit more with arrow in-memory layouts. But we'll save that for a future topic. That was a lot of Polars and pandas code. And honestly, if you ask me, is Polars worth all the hype? I would say yes. Yes, Polars is worth the hype. It's an amazing tool, and while it's not going to be fully supported yet in all of your favorite libraries, you can use it to make extremely robust and fast data transformation pipelines. That's where I see Polar getting most of its use, is expression syntax, and the methods that are exposed on the data frame and the series-like object are all going to be very beneficial. The documentation is fairly straightforward and easy to work with, and in Polars, there's usually just one or two ways to perform a single computation. Unlike in pandas, right? Pandas has been around for a decade. We have a lot of different methods that all refer to the exact same thing. And so pandas does get a little confusing with its very broad API. Polars has gotten a little bit more narrow, and you can comprise a lot of the functionality in specialized pandas with just the expressions from Polars, and that is what I think its real shining point is. The expressions are incredibly powerful, and I'm very excited to see what you make with Polars. I want to thank you all for coming to this session. We've investigated the hype on polars, and we have confirmed polars is in fact worth the hype. I would love to hear your thoughts in our Discord channel, so make sure you check out our Discord channel. But if you don't, I will see you all next time when we talk a little bit more about in-memory data frame or data table representation. Thanks for watching. If you enjoyed this video, give it a like, hit subscribe, and check out the recommended video on the screen. See you in the next one.